way into the mining industry. Today, we're going to be talking to you about GHG reduction and cost savings via heat exchange ventilation technology for multiple industries. So this technology is application for the agricultural industry, for the forestry industry, for the food industry, and for many other industry applications, as well, of course, as mining. Before we jump into the presentation, I would like to take a few moments to just give you some of the house rules for this presentation. What we'll do is for the next, over a 20-minute period, Lane and Daniel are going to present the presentation to you and share with you the insights into the heat exchange technology. And then following that is going to be 10 minutes of questions and answers. For those of you who wish to ask questions, please type them in the chat box and we'll be able to read those questions out and have them answered by Elaine and Daniel. Also, what we're going to do is at the conclusion of this presentation, we're going to take the video and put it on our YouTube channel. And I'll be sending you all a link to the YouTube video and also sending you a copy of the PowerPoint presentation. Right, so without any further ado, let's turn over the floor to the virtual podium, Elaine and Daniel. Elaine and Daniel, welcome.
Hello, everybody. Thank you for watching, attending to this webinar. My name is Ellen Palmeira. I am International Marketing Manager at GUPEX. And today I have with me my colleague, Danielle Clough, Dr. Danielle Clough. If you could introduce yourself, Danielle, please.
Well, good afternoon, everyone. We have CanMind Associates, and I've been involved in the mining industry for over 30 years now. So we work on thermodynamics and so on. So I'm very happy to be here.
Great. So today we're going to talk about GHG reductions and costing savings through heat exchange ventilation technology. This technology can be applied for multiple industries. Before I go any further, I would like to just a short introduction about GUPEX. We are a ventilation company with more than 30 years experience in the market. We are specialized in manufacturing air-to-air heat plate exchangers and heat recovery units. What makes our units stand out from the other technologies is that our units are made of glass fiber reinforced polyester. This makes our product resistant to humidity, to moist, to polluted and corrosive air environments. Later on, I'm going to come back and talk more detailed about this, those units. But for now, Danielle can talk about your company, please.
Okay, thanks, Ellen. Yes, we've developed a new chilling technology based on cryogenic liquids. So we can deliver a system that will essentially take the heat from your mine in an underground system and convert it to electricity. Using the same liquids, we can also provide you with compressed air that in the process of doing that provides more chilling. So this really adds up. We're in the process of doing large-scale testing right now, and we invite everyone to have a look at our future webinar.
Thank you so much, Danielle. Let me see. So before we go any further, it's just a little brief about what plate heat exchange actually is. It is a type of recovery heat and exchange that it's usually installed within the supply and exhaust air streams of our air handling system, ventilation system. Basically, it is two neighbor plates that, as you can see in the drawers, that creates channels where the air can pass through, the exhaust air and the fresh air, and those two do not mix. We're going to talk, as I said, about other industries, and to begin with, Danielle's going to have a short presentation. How does this work in the mining industry? So.
Okay, thank you, Ellen. Well, you all know that the air coming up your upcast shaft has heat in it. especially in the wintertime. You heat the air before it goes down. So what we do is we capture the heat from that upcast shaft through this heat exchanger, and then the fresh air coming in does not mix, and you take advantage of using that heat instead of propane, natural gas, electricity in the wintertime to warm the air in the downcast shaft. We found that this can lead to substantial greenhouse gas savings or just energy savings if it's electricity. And depending on the size of the project, there's different payback periods. But also, in the summertime, we're integrating Ellen's system at Gupex into cooling. So in the summertime, we can use the exact same heat exchanger to provide air conditioning for the mine.
So here, thank you, Danielle. This is a little bit just short benefits about that brings with our technology. First of all, and mainly is the GHG emissions, and there is no GHG heating system, and there's no mechanical moving parts, no maintenance. We have an efficiency of around 65%. This all improve your company green profile. It is extremely resistant to corrosion and acids because of the material that is made. We also want to say that it's a low pressure drop through the heat exchange. And it is self-cleaning, something that I also will explain in some of the pictures later on. We have some information here about the deliver time. This is one of the cases, and this is mainly when it comes to mining, where what we can promise deliver. Here is a great picture that I always like to have, that when it comes to investment, I can happily speak that is a great investment when it comes to durability and sustainability. This is one of the first units that we installed. It's been working and running for 30 years without maintenance. So you can see the first picture for 30 years ago, and this is how it is now. The material, mainly we have plate and we have the house. The plate, as said, is a glass fiber, and the gap between the plates is 15 millimeters. This gap provides a very great self-cleaning system, because it creates, when the heat exchange is in use, it generates a lot of steam that converts to water, and this water runs through the plates and clean itself. So no particles, no clottage problems with the plate. The house is also made in glass fiber in a sandwich design, also as well resistant to corrosion, and also very light, so it's very good to transport for to transportation. And insulation properties are the best you find out in the market. Here are some of the projects we have delivered. Mining projects. Let's see. Go to the next one. Yeah. We have delivered to Boliden. We can see it's quite easy to assemble. It's solid construction that you can ship through boxes, and is a Lego type of built-in construction. We have the inspection doors. And here is another one, is a Zinkgruvan. We actually have 3 that been delivered there. Those here you can see 2 of them, Thorax and Cecilia. We design because we manufacture and we design and we build the product, we can suit the needs of every client. Mine sites tends to be unique, and in this first one that you can see to your left, it is a construction that was built in the top of a burning station. So we take into consideration to adjust with the needs of our clients. If Danielle could talk a little bit about our payback time.
Okay. The payback periods, as Ellen said, each situation is unique. So we just did a study for Lakeshore Gold, and their payback period based on propane consumption would be about 2 years. Now, historically, in the past, there were longer payback periods, but we think that's coming down a lot because costs are going up, but the cost of the systems aren't going up in as much as energy. So depending on your life of mine, once this is paid back, you're forever saving on all of those energy costs, which in the small cases were a couple of $1 million a year. Plus, you're going to be moving forward with all the greenhouse gas benefits. So you're not going to be paying for tons of carbon, and those prices are going to be going up. So forward moving, this saves you money, and the savings can actually increase over time.
Yeah, and then just one extra thing when it comes to the drying process, it depends as well. It can vary to 1 to 2 years depending on the temperature that we are talking about. It tends to have a very high temperature and humidity. If you're talking about 60 degrees or if about 90 degrees, it's going to vary in the payback time. Here, as I said, you have all other types of industry that this is just to name a few. It's not the list is not complete, but those are the industries that we have been working with and we have succeed. And mainly, I'm not going to go inside of specifically how does it work, but why these companies choose our product is pretty much because when it comes to welding, metallurgic, and aluminium, it is pretty much because we are corrosive resistant and we are particle resistant. So there is no clottage on the unit. Spray dryers as well, the same. Wind turbines is in the non-cell. It is very corrosive and humid, and there is the problem with the salt most of the times, and it tends to be quite hot. So in this situation as well, in the situation of some minings, we can provide cooling. Electrical plating industry and wood and food, it's as well because of the dust and humidity. And the farms also because of all the particles that there is, and the fishing as well because of the salt. So there is a lot of characteristics in our product that made it stand diverse from all the others that is in the market. So we could go talk about this for a long time, but I'm gonna let it in here. Here is just another diagram about spray dryers, because this we also have a very good knowledge and we have delivered many of those. Here is simple. The whole process happens pretty much as it is in the mining. You take out the heat that tends to be extremely hot and humid, and you go through the heat exchange and you reuse it. So you can see the temperatures from 10 to 15, 90 is just an overview of how does it work. Again, this is all the benefits we have when it comes to this to the solution we present to you today. Danielle, if you have something more that you would like to add, please do so.
Okay. Well, I guess there was a question about what happens to the heat, because then it already warmed up or something. So I'll just go into that in a little bit more detail. Okay, so first of all, you need to heat your downgoing air to somewhere around 2 to 4 degrees in the wintertime. So if the temperature is -10, you're heating the air to 2 to 4 degrees, and it's more and more heat is required as the temperature goes down. what we do is we capture the air that's already going in. So we're warming the air using the air that went through the mine. So first of all, you've got the auto compression. So if you go down 2,000 meters, you heat the air up to 2 degrees at top. By the time it gets to the bottom, it's going to be 17 to 20 degrees C already. Then it goes through the mine, picks up any heat from operations or strata heat that's down there, and then it comes back up. Now on the way up, it cools down a bit, the reverse process, but it also has humidity and it's warmer than it was when it started. So when we mix those two flows through the heat exchanger, it's only the heat that transfers, none of the air mixes. So in the end, you end up not having to turn on your heaters till a much lower temperature, like below -20. So the savings you're getting is everything that you would have spent heating the air between 2 degrees C and down to -20, which turns out to be a lot, quite frankly. This is in the millions of dollars, depending on the propane or natural gas is a lot cheaper. And that's what also goes to the payback period. If you're using propane, which is, I don't know, sometimes it's 3 times the cost of natural gas, then the payback period is a little smaller. If you're using natural gas, it takes a little longer to catch up. But once you do, you've got years and years and years of free energy that you're capturing from the mine and reusing. So I hope that clarifies that question.
Okay, thank you, Daniel, for answering that question. Another question that come up in the chat room is how close do the exhaust and fresh air shafts have to be, in your experience, for the solution to be viable?
Well, that's a really good question because, as you know, this vent ducting is quite expensive. We do have to basically connect the 2 shafts. So the farther away it is, the more expensive it gets. Now, when we were looking at a local mine, the distance was about 500 or 600 meters, depending on which way we went there. And that was still viable, even though the cost of the ducting was going to be well over $1 million. It's part of the cost. So what we're saying is, we know we need lots of mines. There's not enough copper to meet all the clean energy technologies and so on that are coming up in the future. So if you're designing a mine, put the shafts as close as you can. That's our recommendation. And it works out very well in the end.
Okay, Elaine, did you want to add something to that?
For new projects, as Daniel was saying, this is a great investment when it's a complete brand new mine where you can design exactly the distance. But we have delivered 300-400 meters without any so much increasingly on the costs. And as well as I just would like to add to Daniel, when it comes to the mining industry, some places and some mining, depending on the temperature you're dealing with, you might not even need an extra burner station or an extra heat income. And you can use just the heater exchange, just pretty much our plates without anything more. And we have this situation also in Sweden that we can show how it is being working there.
Okay, awesome. Thank you for that. Another question I have here is, what do you say to a company that says our energy costs are very low? And we think that we don't need to get this heat exchange because the cost savings are not going to be that significant. How would you comment to that?
Well, what do you think the future price of these natural gas and fossil fuels is going to be? What do you think the carbon price is going to be? And those are going to go up for sure. But on the other side of it, you need to start having in your portfolio some measures that you're taking to demonstrate to your clients and investors that you're doing something to reduce carbon emissions. And this is a very easy thing to do. And it gets you some of that green profile that you can use as because I can tell you for sure, looking at the markets, investors are starting to talk with their dollars. If you're not finding a way to reduce emissions, you're taking a hit in the markets. So this is important moving forward. Take a look at a 10-year profile instead of just the next couple of years, and look at what happens after your payback period.
Sure. All right, thank you for that. Another question here is, are there any issues with ice forming on the plates as the humid air cools down? And if so, do you deal with it? How do you deal with it, and how frequent?
Okay, that's a good question. Now, here's the thing. We adjust the airflow going through the heat exchanger. So even if the air coming in goes down to minus 45 or minus 50, it still doesn't ice up, because you're trading heat, right? You're exchanging heat. So there's enough heat there to make sure that the cold side doesn't freeze. And that's part of the system. So we have systems in place that manage the flows to make sure that doesn't happen.
We can also, just to add about this, that's true. But if there is in very, very few cases, this situation, we deal with it with bypass. We have, so we can also offer bypass defrosing, as we call, unit or unfrozen unit. So it deals with bypass, so controls exactly what Daniel said, this heat that comes in and out. So then there is the issue of freezing, it's gone.
Gotcha. Yeah. All right, thank you for that. Daniel, do you want to add a bit more to that before we go to the next question?
It just doesn't happen. We've got that managed.
Okay, gotcha. All right, next question is, can you elaborate more on the cleaning of the heat exchange, since most mine exhaust systems consist of dirty air?
Do you want to start, Ellen, or should I just...
I can take this. Well, so actually we can see in the picture that you have right now, this is a very good example. This is in Zinkgruvan. You can see there is a lot of steam that comes out from the top. This steam turns to water, and pretty much it runs through. You can see most of the constructions that we have. Also on the one behind here, right on the top, you can see that there is some steam. And normally they actually built some kind of a pipe or something just to put out this water that comes from here. So the plates are pretty much clean all the time because of the steam that the heat exchange produces.
Okay, so now this is an important question, because there are other systems that I've looked at. The first time I came up with this, I did some research and so on. There have been other heat exchange systems put in place. We did some testing with aluminum at Lakeshore, and we determined that you would have to clean the system every 6 weeks to 2 months, 6 to 8 weeks. You'd have to be in there cleaning the system. And when those particles build up, it changes the heat exchanger flow characteristics. It changes the thermodynamics characteristics, and eventually it blocks up. And there have been of these that have just been shut down after 3 or 4 years because they didn't work anymore because of a lack of maintenance. None of that is required here. And it's basically because of the setup of how the plates are set up, they're vertical, and then there's the type of material. This material is remarkable compared to all the metals and things that heat exchangers are made of. So that problem is identified in the first slide when Ellen said it's been there for 30 years with no maintenance. That includes cleaning. Didn't have to be cleaned for 30 years. Just runs out the bottom, and then you ship that off to wherever you want.
Exactly.
Thank you for that answer. Okay, next question I have here is a question around the glass fiber and where that is constructed. If you could comment on where is the equipment and the infrastructure required for the heat exchange system manufactured?
Well, our system is built in, the plates are built in the US. So it is American product, you can say. And the houses are built in Sweden, actually. So we are moving eventually our also production, totally production to the US. But because up to now we have in 2 different spaces, and we are very happy with the companies we've been using so far.
And that's for the raw materials. The design and everything is done in-house, and then they just say, we need plates like this. It's very similar to a fiberglass system that has the fibers in it and so on. It's a phenolic resin. very durable, very strong, temperature resistant as well. So
the plates actually, they were designed in the north of Norway, in a university in the north of Norway many years ago, and they are designed to, there is if you see our plates, there is some bumps in it that creates a turbulence inside of the plates that makes the efficiency better and compensate for other, because some of the questions we get is about aluminum, why not use other types? And pretty much our up to now, the glass fiber has first don't get corrosion, don't have oxidated, and because of the small details that we have in our plate, and very specifically details that there is characteristic that there is in the plate, it comes up in the same efficient as if it would be some other type of material.
Yeah, once you use this, you'll never go back to aluminum. Even polished stainless steel ends up getting fouled and corroded over time and has to be cleaned. So this is the product you need. This is the material that you need.
It looks like we have time for more question, and thank you for the answer so far. Question is, can you elaborate more on the carbon capture applications of this technology?
Well, we're not doing that. We're stopping you from creating carbon. So if you have to heat the air on the intake, then you're burning propane or natural gas. So if you're not doing that, you're not creating carbon. This just sits there. Once you install it, it just sits there and doesn't do anything except transfer heat. And we can transfer heat from all different sources and so on. So that's it. It's reducing your consumption on the site, and very substantially, I might add. Now, don't forget, there's an upcoming webinar that's going to explain how we use the exact same system in the summertime to do cooling. So once it's installed, you can cool in the summer.
Okay, thank you for that. Elaine, did you want to add anything to that?
No, I think that we come to the point.
Okay, very good. All right, with about a minute left to go, I would like to ask Elaine and Danielle to just maybe give any closing remarks before we say thank you to our guests. Elaine, please go ahead.
Okay, thank you very much all for joining us. It's a pleasure always to communicate and to talk about this technology. I personally believe that this is, because I have seen it, is a quite good technology that can innovate and help not just investments, but the environment. And that's something important, especially nowadays. So thank you very much for watching.
Thank you. Daniel, please go ahead.
Well, we hope you don't mind if we send you some promotional material as a result of attending this webinar. And like Ellen says, this really works. We'd like you to look at it a little closer. And in order to do that, we need some very basic information from you. So there might be a slide that you can put up there at the end to just show them how simple it is to provide us the information required.
All right. Okay, again, thank you to our guests for attending. You will be receiving a link in your email of the presentation and link to the video so you can watch this at your own pace. Thank you again. Have a good day, and we look forward to hosting you on our next webinar. Thank you.
Thank you, everybody. Bye-bye.
Bye. Bye.
Bye-bye. Well done.